Aloha. Today we are going to get started with the DCS and learn how to run a sample using the differential scanning calorimeter. So let's get started with our wooden box here. This will have everything that we need to make a sample. So in order to get started, we're going to pull out this crucible stand and a crucible cup, which are the crucibles with the indent. But you can it's more of a cup shape. And we're going to put that right into our crucible stand. And this is where we're going to put our sample. So today I am making a 50/50 bacteria LB sample. And so I'm going to we're doing a max of 20 microliters to reduce the amount of variance in the incline of the curve. And we're going to set the pipette to 10 microliters, so we can get 10 microliters of LB and 10 microliters of the grown bacteria. And so today we're testing Pseudomonas aeruginosa. So I'm just going to tip this over, and this would be much safer with longer tips. So I would recommend going and finding some longer tips instead of doing what I'm doing. Okay, and I check my sample, make sure it's in there, and then I'm going to squirt it into my crucible. Now, something important to remember when inputting a sample into your crucible, this is going to be after we add the LB, of course, is, if I can show you, I don't know if you can see it, but all of the fluid is stuck to one side of the crucible, and that is not what we want. That will actually give us jumps in our curve. And so what we're going to try to do is, after we add the LB, we're also going to mix the two together, and then additionally spread it around to all sides of the crucible. Something else is that I always use these tips called filter tips, and they have a little filter right here, and it's just to prevent, just in case you misset your pipette or something goes wrong, the fluid, the bacterial samples that you're working with, doesn't get shot up into the pipette. And so this is just a way of protecting the pipettes from getting contaminated with bacteria. Okay, so again, 50/50 solution. Now I'm doing my LB sample, and this is clean LB because it's clear through and through. So I'm just going to take another 10 microliters, check to make sure it's there, and then I'm going to mix it in with my bacterial sample slowly, just in case, to make sure that we're not ripping any of the bacterial cells that are in the solution. And I'm just going to turn the crucible to make sure that I get the sample on all sides of the crucible so that it's evenly coating the bottom of the crucible so that there's no uneven cooling or thawing. And then I always just check the pipette tip to make sure that there's nothing left in there. And if there is, an easy way to fix it is by pushing the pipette tip down a little bit, making sure that nothing comes out, and you slowly suck up just enough liquid to grab on to the remaining fluid in the pipette tip. And then you push out, and you just do that until you get all of it. And that's just to make sure that our samples are always the same measurement of 20 micrograms. Okay, so then we're going to move on to our crucible lids. And we're just going to open these, and these have a slight indent one side is indented, one side pops out like a bubble. We want to pick up the caps with the bubble side up, and then we want to place it carefully on top of the crucible cup. And whenever I do this, I always put the tweezers on either side of the crucible cup, and I just shimmy it around to make sure it's on there evenly. Okay. So now we have our crucible made, but it's not ready to go yet because it's not sealed. And for calorimetry, it's very important that we have a closed system. So what I'm going to do is take this crucible clamp right here. This handle comes down, and I'm going to insert the crucible stand, and I'm going to put it into the slot right here. I'm just going to spin it until the crucible falls into place. This is important because when you're pushing metal against metal, sometimes it can get stuck. And I'm not going to bounce this handle down. I'm just going to go straight down, all the way to the bottom, and then straight up. Sometimes this gets a little stuck, so we just pull up on it, and it has a little clicking sound. Okay. So now I have my crucible all ready to go, and we actually have a crucible holder on the calorimeter. This is stand A, and there's another stand B, and all of these have their individual numbers, if you can see that, all the way 0 through 19. And so this is where we hold the crucibles. The crucibles can't be labeled on the crucible, but they can be kept track of with this sheet right here that we use. So here we know that in slot 0, there's a 40 microliter H2O sample. And in slot 6, there's a 50-50 sample of bacteria and LB. And so that's what we're going to do, is we are going to pick up the crucible with the tweezers because we don't want to contaminate the outside of the crucible and affect the curve of the machine. And we are going to put it into one of these slots. And then in a permanent marker, right where I inserted that, I'm going to write what it was. And when I'm ready to erase that, I'll get the dry erase marker right here. Oops. Dry erase marker right here. And I'll go over the Sharpie with dry erase and wipe it off with a paper towel. Okay. So now we have our crucible all ready to go. We have our sample in its correct location in slot number 6. And now we are going to prepare the machine to use it. Oh, also the bacterial samples can be found in the fridge in the biochemistry lab in Dr. Scott's section. Okay, so now we are going to move on to the computer. And I'm going to try to give this as good of an angle as I can. Okay, so the first thing that we're going to do, this is the advanced way, but it's a good way to learn, is there's an icon right here called Auto Sampler. And we're going to open Auto Sampler. And this allows us to do multiple runs at a time. And so it opens this window right here. And so I'm going to go to File, and I'm going to click on New Macro, and then it's going to allow me to title the macro. And so I'm going to call this macro bacterial / LB samples, and then I'm going to write the date. Okay. And now I'm going to click on this icon on the left-hand side of the screen, right over here. You can't really see it very well. Let me see if I can get a better angle. Okay. So I'm going to click on this icon titled New. I'm going to open that. And because I've already performed a correction for this, I'm just going to go right into my sample. So the first sample that I want to run is in, the first crucible that I want to run is in slot number 1. And so it's a filled crucible, so I'm going to click filled, and its mass is 20 micrograms, and the crucible mass is 0 due to the correction, because of the correction. And that's it for that. And then I'm going to go to step data, which is the next tab, and we're doing a correction plus a sample because it's most accurate. And I'm going to title this file back for bacteria one, and then the date. And then the rate at which I'm going to cool and heat this. And this has to be inserted in 3 separate places, 3 separate locations. Okay, and after the names are input, nothing else in this needs to be added unless you want to. And we're going to move on to the measurement. And so this is where we have to input the correction type that we want, the correction file that we want to be associated with this sample. And so we're going to go to select a correction measurement, and all of my corrections for my melting data are in H2O, glycerol, DMSO melting data. So I'm going to click on that, and the first things that pop up are the corrections. And so we're doing a rate of 3, and so I'm going to click on this correction where at the end it says RT3, which means rate 3. I'm going to open that correction file, and it'll take a little bit to load. But after it loads, we can double check to make sure it's the right correction file. So we have the initial temperature at -30, and that's going to be an isotherm, which is green arrow, at -30 for 15 minutes at 20 points per minute of data. And then we're going to have a dynamic interval at which we're going to increase the temperature to 37 degrees at a rate of 3 kelvins per minute. And then we always have an emergency stop temperature at 47. Okay, so that is all for setting up our correction measurement. And then we can click OK at the bottom of this right here. OK, and our first run will pop up. In order to run an additional sample, we click copy, paste, OK. And then we'll have generally the same data, except for this time I'm going to use pan 2, and it has a mass of 20 milligrams, a crucible mass of 0. Of course, we're going to have to rename it, otherwise our file will be written over. So now I have my new file name with the correction plus sample. The measurement should remain because we copy and paste it. Oh, sometimes you have to accept mass so that it can register. And then click OK. Okay, and now that that is finished, we can go to macro, which is the 3rd tab on our auto sampler, and we're going to click Run Magazine. And we only have 2 samples here, but this list can extend pretty far down. And we're going to run these samples, and this is where we choose where we want to save our samples. And so I'm going to save it in Brianna Bacteria. Save. Okay, and then we have a couple of tabs that pop up. This one, just click OK. A lot of this is very generalized. For this tab, where normal completion of magazine, we want to uncheck CO2 if it's not already unchecked to prevent the machine from overcooling, and click OK. And then it will open our regular sample run. And this is how it makes sure that we have the right samples. And so this is something that I wanted to show you. Every once in a while, here at the bottom, we have sample in number 2, meaning sample in the chamber of the DSC, reference in the chamber of 19. A little bit earlier, I had a little mix-up, and the machine picked up on a curve number 6, or number 2, and flipped it, and so the sample wasn't put in correctly, and so I had to remove both the sample and the reference. And in order to fix this, I took the tweezers and I removed both samples from the chamber, as you can see. And now that those samples are removed, I am able to, at this stage, clear the sample, and that will remove the machine's memory of the sample in the chamber. And I'm going to clear the reference. And so now neither the sample or the reference are in, and now the machine's data matches our data because of that mistake with the prongs. Okay, and now that everything's ready to go, we can click OK, and the machine will begin to run what we have asked it to run. And so this normally has a little bit of a countdown, but what's going to happen is these prongs right here will move over to the correct sample and pick it up and place it inside the machine. And the furnace will close, and then the samples will begin to be run. At the end of your samples, you will have curves saved to your files, and you can open up Proteus Analysis, and that's where you can analyze your samples.